Okay, so if you're not familiar with Git and you've mostly used Subversion, the differences between the two can be a little bit confusing. That's because Git and Subversion use different models to coordinate a project. Subversion is what we call a centralized version control system, while Git is distributed. So let's take a look at what that means. In Subversion, there will typically be a sole central repository on the Subversion server, which everybody in the project will use to track their changes. So let's say this is our Subversion server, and this circle represents our repository, which is on the server. If a user wants to check out the current project, they will use the Subversion checkout command. That makes a local copy of the contents of the repository on the user's computer, which is called a working copy. Now, the working copy is not a repository, but it does allow you to send your changes back to the Subversion server using commit or the Subversion commit command, which adds them to the version control history. That works with multiple people as well. If another person wants to work on the project, they can also check out the code in the same way using the Subversion checkout command. I'll add that over here too. And they'll get their own working copy, which is also not a repository, but it does allow them to make changes, which I'll represent using a delta there, that they can then commit back to the repository using the Subversion commit command, and it will be added to the version control history. There is also mechanisms for handling, say, conflicts, if both users were to make changes that conflicted with each other. So the question is, how is that different from Git? Well, in Git, there is no central repository. Each user working on the project has their own repository on their own local computer. When you commit a change, or any change you made using Git, it is stored in that local repository. So, if this is our user, and they create a repository on their own computer, so this is user A's computer, if they make a change and they commit it, it's stored locally on their computer in that repository. There's no server involved. Now, if somebody else wants to work on the project, say user B, there's user B's computer, they can create a copy of their repository on their computer using the git clone command. So clone copies the entire repository, so the new user has an independent and fully self-contained copy of the repository on their system. So that's the same as A's repository, but it's not A's repository, so I'll actually label it B. Now, that was done using the git clone command, so I should add that there. If they make changes to their repository and commit those changes are committed back to that repository on their local machine, not to the original repository. So, what if A and B want to share? Well, that changes can be moved back and forth between repositories by using pushing and pulling. If B commits a change, like this, to his own repository and wants to share it with A, he can use the push command to transmit those commits to A. So he can share that history using the git push command. Now, those commits have been added to A's repository as well. But what if A committed their own changes in the meantime? Well, there's another step that B should take before pushing their changes to A. Namely, they should first pull the changes from A's repository over to their own, so they can resolve any conflicts that might arise. Then he can push his changes back to A without problems, and both repositories will be synchronized. So, now what happens? Well, consider this. There's a problem with this setup. A and B on their local computers are probably not connected. It's unlikely that two people will want to open up their hard drives and their Git repositories on their local computers to the world so that their friends or anybody working on their project can commit, push, and pull to those repositories. So, the solution is GitHub, or some third party. That's where GitHub comes in this case. GitHub hosts a third repository on a GitHub server, which I'll draw here, which is publicly accessible to the general internet. Therefore, even though A and B can't directly communicate with each other, each of them can push and pull from that central repository without a problem. Also, it provides a gateway for the rest of the general internet, which I'll make with this cloud here, to access that code and get a look at what's going on in the project. So let's say Steve wanted to check out the code for this project. He can just clone that repository to his local computer, and he'll have a copy of the project. But he did not have to access A's repository or B's repository, and he can't even see them, so he doesn't need to know that they exist. And that is basically the purpose of GitHub. So, that is the difference between Git and Subversion. I hope it's helpful. I'll make another video on how to actually do that with GitHub. So, and also Git from the command line.